All right, so I want to just use today to give you some time to kind of marinate what we've been doing. If you have questions, I want to ask them. I want you to ask them first. If I skip some problems, like I think I skipped that wolf problem and the oil problem, it's just because over the years I've just realized that we've spent way too much time on certain sections, so I'm just kind of trimming some of the fat off. But anyway, so I'm jumping, I think this is what, page 33 or so? Yeah. 33. And but if you have a question on anything, homework question, whatever, ask me now so we can kind of get that addressed, and then we'll jump into some of these random problems. And then tomorrow, I was thinking we were going to do Newton's Law of Cooling today, but I'll start Newton's Law of Cooling tomorrow. Yes, sir.
No, I haven't. I just need to find the homework page.
Anybody while he's looking have any question with anything that you feel will sketchy?
25.
27?
25?
25?
Mm-hmm.
Sure.
Yes.
Nobody?
Okay, like minor question. Do you
Yeah.
want us to round to 3 places or 2 places?
Always 3 in AP Calculus.
Okay.
Always 3. You can go 5, but whatever you write past 3 has to be perfect. So it's a whole lot easier being perfect with 3 a lot of times than 5, but you have to round to 3. Now if it's a whole number, you don't have to write like 25.000. And if you don't have a calculator, you probably won't be rounding anyway. You'll be leaving exact values or, fractions or whatever. But if you have a calculator and you choose to write a decimal, it has to be 3 decimals.
Could you do number 12 on page 22?
Okay, so number 12. Okay, so probably will never see a question in this form, but I do need to separate variables, right? So I'm looking at number 12 and I see a D big T and a D little t. So there's definitely a difference between those. And this is saying when I plug in a value of 0 into the big T function, so what must that value of 0 be? A little t. So when I plug the little t of 0 in, my big T gives me 140. So I'm going to get, since I kind of like I like y on the left and x on the right, or y on the left and t on the right, I'm going to get big T on the right and little t on the left, because that seems to be how this function is written. So I'm going to keep the big T there, and you'll find in AP Calculus you don't do a lot of subtracting when you're doing separation of variables this way, although on this one it's the only way to get the little dt over there. So because all of this is multiplied together, it's stuck together, I've got to move all of it over at once. So when I subtract all of that at once, I get here. Okay? Now I've got to get rid of the big T values over here, because that T minus 70 is kind of joined together. I can't really separate it. So I'm going to divide all of it over to the left. So I'm going to divide all of that big T minus 70 on both sides. And that leaves me technically 1 over big T minus 70 d big T and negative k dt. And that's separating my variables. That would have been a point. But honestly, you don't see a lot of this kind of math. You would in differential equations. If you took that as a course, you'd see all kinds of manipulations that you have to make algebraically. But in AP Cal, that's not very common. Okay, so at this point, I've got something that I can work with. So I'm going to integrate the left side, and I'm going to integrate the right side. You can integrate there. Since both of those are constants, I can factor them out if I want. Now, that's not on my sheet, but it's close, right? So if I say u is t minus 70, then my derivative of u would be the derivative of t, which is 1 dt minus 0, right? So basically du is dt. So all of that is my du, that is my dt, and I am ready to go with my integration. So integrating that gives me ln absolute value of u. I'm going to go ahead and plug that u back in there. Integrating that gives me
KT.
t with the negative k already there, right? And then I've got to exponentiate this thing to get rid of my natural log. So I'm going to exponentiate with the value of e, because that's log base e, which is going to cancel this. And then what do I do when I exponentiate something that has a plus c as the exponent? Swing that c out to the front. And again, I'm not going to keep talking about the algebra that hopefully you saw us talk about that in the video or in class yesterday. I can swing that c out to the front and leave anything else still up there with the e. And at this point, absolute value gives me plus or minus, but what does the c do to that plus or minus? Kind of absorbs it or swallows it up or whatever. And then I got to add a 70. So CE to the negative KT plus 70. Now, I personally don't like solving for C here. Like I could have done this. Like right here, if I come in on this problem right there and go, all right, time to solve for C, I'm going to plug in the point 0, 140 in here. If I do plug a 0 there and a 140 in there, I get C equals natural log of absolute value of 70, which is natural log of 70. I can do that. I can plug ln of 70 in there. And if I do that, my math is going to look different. Because now with ln of 70 right in there, isn't going to swing out to the front, is it? It has value now. And your answer will look different than mine. That doesn't mean it's wrong, it just looks different. You'll think you're wrong, but when you come and ask me, I'll go, hey, look, if you really do the math on this, do you see why? And you're going to go, oh, yeah. However, I like waiting. If I'm going to solve for C, rather than have this really ugly value, I'm going to go ahead and try to clean it up a little bit. So I kind of like plugging in the 0, 140 in here. Because if I plug in little t0, big T 140 here, look, it just feels nicer. Right? I get CE to the negative K times 0 plus 70, and all of that cancels because all of that's equal to 1. So all I got to do is subtract a 70, and I get C equals 70. And I don't plug 70 there, right? I plug 70 into the equation I used when I inserted the point. So I'm going to plug the 70 there. Are you tracking with me?
Right.
You have to plug it into the equation that you use to solve, and that right there is not the same thing as this right here. Here you would have gotten a different value for C. And the more you do your homework and the more you look at my keys, the more you'll see perhaps that your values of C are not the same as mine. And that's because they can change as you move through this, right? Here it's a C. Here, that really is what? Not C, but E to the C. That gives you a different value. So your C values might change the way it looks, but it's not going to be wrong. I will say, however, you're rarely going to see an answer on a multiple choice question that's going to have an ln of 70 or something up there. You're not going to see that. You're going to see this value of C. So the more experience you get and the more your work starts to resemble my work, I try to put work out there that is the way AP does it. Okay? And on a multiple choice question, it's not going to matter. The teachers there that grade the papers are bright enough to be able to go, oh, I see what they did. But on a multiple choice, on a free response, on a multiple choice, you might get yourself into trouble because your answer might not look like one of those. So anyway, now that I have my C, I'm going to plug this 70 back in right there, and I get T equals 70 e to the negative KT plus 70. And AP even sometimes does this. I don't know why they do this, but sometimes they just decide to factor it. But I don't know why they would do that. That's dumb to me. I would write this. And I can't find that K value unless I have another point, right? But that would be my growth constant. That's going to change the way the curve looks. But I don't know what that is. I would have to have something else given to me, some other point given to me to be able to get anywhere. And again, if I'm grading this, I'm probably going +1, depending on how difficult the integral is. These are pretty basic integrals, so probably like +half for that, +half for that, +1 for remembering the plus C. Already you're at 3 points, and then +1 for entering that point in. Now you're at 4 points, and +1 for writing that equation solved for T. So So that's a 5-point problem on an AP test. Sometimes it's even 6, because sometimes they go point right there. And it's there every single year. I can't predict what's on the AP test. I could say, hey, out of these 500 problems, you're gonna have a bunch of them, kind of like I do on an exam review packet. You know, when I give you an overly big packet, but say the test is in there, I can do that, and we will do that in May and in March and April. I'll overload your information. You'll see, I would argue, 95% of what's on the AP test a number of times. There'll always be some creative things they come up with. But that, man, you can bank on this. You can bank on volumes of rotation, or you can bank on area between curves. I mean, certain problems you know are going to be on there day in and day out. And it's worth knowing, because you can stink at calculus. You can be not that a C student is stinking, because you might be working really hard, but like you can make C's in calculus and still make a 3 or 4 on the AP test just by cobbling together enough of that information, if you're willing to work and really willing to learn. This is such a common problem, except they wouldn't start you here probably. They'd probably start you like maybe right here. That would be a more common way to begin. All right? Okay, let's jump to the work we plan on doing today, and help me along with this. And again, make notes to yourself if you're struggling with any of this. Make sure that you're putting yourself in a good position to do well. So this was a 1997 problem, which was a long time ago. It's a long time ago. My 4th year in the building. All right. Yep. 4th year in the building. And we're starting out with a velocity question. So it says, let V be the velocity in feet per second of a skydiver from time greater than or equal to 0. Okay, it says, after her parachute opens, her velocity satisfies the differential equation given here with that initial condition. So it says, eventually, basically, she's starting at -50 feet per second. All right? This is kind of an interesting question, because she's starting at 50 feet per second, going down, right? That's her velocity. You know what gravity is?
Yeah.
What?
It's about 9.8
meters per second. Do you know what it is in feet per second?
32.
32?
Yeah.
So what's going to end up happening here?
She's got to do it fast.
Gravity, literally, she's being shot out of this building. I mean, out of this plane. She's not just jumping out of velocity of 0 and then accelerating. Her acceleration due to gravity is actually, it's possible that, well, I tell you, we'll get into it later. Now, look at the answers and then I'll ask you the same question. I think this is the one that does this. So here's my differential equation. There's my initial condition. It says use separation of variables to find an expression for V in terms of T, where T is measured in seconds. Y'all know what they're saying there?
Yes.
Another way they could word it is find the solution. Now it says for V in terms of T. So basically V equals something with T in it. All right, so let's get started. How would you separate the variables?
TV plus 2V.
Okay, I'm glad you said that. She said add 2V. So if I added 2V though, I'd get this. Now that's a little odd, right? Because now how am I going to get the dt? Don't do this. How would I get the dt over? I'd have to multiply it, but if I multiply it, I'm going to get rid of it there, but I'm going to put it there. So I start running into trouble, don't I? And you'll notice on all the problems we separated variables, you never had anything added to dv dt or dt or whatever. You never had anything added. It was always multiplied. So what I need to do is to get the dt over here and the v term over here. So give me another idea.
Multiply dt across.
So if I multiply by dt, I'm really multiplying the whole side by dt, right? That gets me to here.
And then you just divide -2v minus 32.
Now, that is totally fine. But he said to divide by this. So if you do that, you're going to end up with -2v minus 32. Cancel, and you would get this. Can anybody think of a better way to do this? And the reason I'm saying better is you definitely separated variables, so you did your job. But in the end, what are you going to be doing? Solving for v, which you now have all this extra crap over here that you're going to have to deal with, aren't you? You got that negative 32, which is, you're still going to have to deal with some kind of value there. But you also have a negative 2. What could I have done? Somebody? Yeah, what if I factor right here, factor out a negative 2. Are you with me? Now, the only thing I have to divide over is v plus 16. So, to me, this is a much better plan. It makes the u substitutions better. It makes the solving from that point further better. I gotta be honest, when you look at my work, I actually divided by negative, I did this. If you look at my work, if it is on school, because it's classwork, it might not be. I did this first, and then I said, you know what if I just factored a negative 2 out of that? And then just multiplied both sides by a negative 2. So I actually didn't factor initially. I did this, and then I factored one, just because it makes it easier to deal with. The u substitution's better. Like, think about it. If I do u substitution with this, because that's not on my list, that's not on my list of rules, then my du is negative 2, right? dv, and I gotta put a 2 in there when I integrate. I gotta put a, I gotta put a 2 in there. I gotta put a 1/2. Then that 1/2 is still there when I solve. I got to multiply both sides by 2. It just creates all this extra work. But look at this. When I do u substitution here, my du is dv. So when I integrate, there's my u, there's my du. I get a nice clean integral with not a whole lot other junk going on, do I? So anytime you can leave on the right stuff you don't need by factoring and just dividing over what you need, you're going to be in a better place. So you can see right here, I integrate and I get natural log absolute value of the u, negative 2t plus c, and then I'm going to e both sides and I'm on my way. But I kind of want to show you, swing the c over, let the c eat the plus or minus, and then subtract the 16. And then now that I have that, it does say use separation of variables, divide expression for v. I did that, but I have it in terms of t and c. So if in terms of t, I want to go ahead and find that c value, and I can do that, right? I've got the point, so I'm going to, at this point, plug in the point when t is 0. V is negative 50. Plugging in a 0 in there makes everything go away except the c, and my c is negative 66.
Why did it minus 16?
Yeah.
Oh, because I made a mistake. Thank you. Which means that is a negative 34. So, my velocity is negative 34, e to the negative 2t, plus minus again, minus 16. And the math checks out too, right? If I plug a 0 in here for t, my velocity is negative 50. What if I plug in 1,000 for t? How about this? What is the limit of my velocity as t approaches infinity? That's a great, did they ask this? Look at that. Wasn't even looking. Great question they like to follow this up with. And this is where my second question will come in that I was asking you earlier, and then I said forget about it. How would you find the limit of that? Is there a way you can maybe rewrite this to help you think?
Did you rewrite it as negative 34 all over e to the 2t?
That's what I would do. I would write this as the limit as t goes to infinity. I don't really like that negative exponent. I mean, I know how to deal with it, but I found my students feel better making it a positive exponent.
I said it feel better.
You feel better already? I mean, look at that. What happens when I plug an infinity in there? What does the bottom doing?
It approaches 0.
It's getting massive. What's the top doing? Fixed. What's the fraction doing? Approaching 0, right? So what's my velocity at infinity?
Negative 16.
Which means what?
That's terminal velocity.
Which means I'm slowing down. Literally, I jumped out of the airplane and I slowed down. Is that possible? Sure. Yeah, you got friction due to air, right? If I take a piece of paper and I throw it down off of a building, right? It might leave my hand in my prime at 75, 80 miles an hour, but what does it immediately hit? Air, and it starts floating. It's totally possible. So if a human got projected out of a plane, which would be a heck of a way to parachute, right? I'm gonna shoot you out.
Headed down when you jump out of it.
I don't think it's.
Yeah, we should do
Yeah, it's possible.
Which is how they do skydiving.
Once you get
Head the
Yeah.
plane down?
It says
Not
after
like
the
straight
parachute
down,
opens, so I think it's more she's fallen for a while and then the parachute opens
Maybe
and
they
then
just
we
had a
start
cannon
doing
on
the
the
calculations.
Yeah, I like that better.
Yeah, I'm a fan of the cannon.
Oh yeah, I like the cannon. That's
Yeah.
it's cooler. No, you're right. I didn't read the question. Are y'all with me on this though? Okay. So there's my equation. There is my part B. And then it says it is safe to land when her speed is 20 feet per second. At what time t does she reach the speed?
Plug it in 20 feet.
Yeah. So if I plug in 20, I'm going to erase this velocity. If I plug in 20, I can solve.
And we get a calculator on this, right?
If you didn't, you would just have a really ugly looking answer. But this is what number, usually I get calculators on 1 through, well, that's weird, 97 might have been different. Usually number 1 and 2 are calculator problems now. It used to be 1, 2, and 3. 4, 5, or 6 were not. But this is clearly a calculator problem. At least that's the way I work it. So, and the key looked like this. So if it were me, if I was doing this, assuming you did not have a calculator, this is what you would do. You would add 16, which would give you this. You divide by negative 34. You'd natural log both sides, which at that point, this thing falls apart, doesn't it? Hold on, let me make sure I didn't do this thing. Oh, her speed is 20 feet per second, but its speeds go, if the speed's 20, what's the velocity?
Oh, yeah.
Negative 20. Yeah, that would have cost me. So the velocity, if the speed is 20, but I'm going down, that's a negative 20 velocity because I have to use the velocity unit. So now when I add 16, I get a negative 4. When I divide by that, I get a positive 4/34, right? And then I would natural log both sides to get rid of the e. And you're fine to leave stuff like this. That gets rid of the e. And then I would divide by a negative 2. So your t is whatever that is. And when you type that in your calculator, you end up with 1.070. And it's time, so it's meters per second. I mean, sorry, so it's seconds.
I like this unit. It's like fun algebra.
Yeah, a lot of people like this unit, I think, primarily because they know integration. It's not like they're really learning any new calculus. Some of you guys are really good in algebra anyway. So it kind of feels in a lot of ways like you're not really learning anything new. You're just taking something you already know and throwing it together. But to each his own. Not too bad?
Not too bad.
Feeling good about this? That's a 9-point problem on an AP test. 9. You need 40 to pass. You know what I'm saying? So this is the kind of thing that, this is something you really got to lock in and go, I got to understand differential equations. Of course, they threw a little limit problem in there. The limit problem probably would have been worth 1 point. Part A would have been 5 or 6 points. This would have been one, in fact, I might have a key right here. That would have been 1 point, probably the limit problem. And sometimes I put the actual, no, I don't have it. I get, on a couple of these problems, I actually have the old AP, the way they point everything out. But I'm guessing part A was 6, part B was 1, and then part C was 2 points. Solving the whole system out. All right, moving on. This is 2013. So to me, this was like yesterday. I know you guys were like in, what were y'all?
2013 was the snowpocalypse, right?
You were fourth grade, fifth grade, fourth grade. Yeah, you guys are a little bit, to me, this is like my second year of teaching calculus, maybe third. And it seems very familiar to me. So this is 2013, AB number 6. This is pretty sure that's a non-calculator. It looks very calculator-esque.
Pretty sure.
Nope, non-calculator problem right here. Okay, so here we go. It says write an equation for the line tangent to the graph of f at that point. So again, it's going to end up being a differential equation problem, but they threw a little tangent line approximation in there for fun. So how do I find an equation of a line tangent to an f function? What do I need? For any tangent line, what do I need? A point and a slope, and then plug it in, right? Well, I don't have the actual function, but they did give me the point. And then what is a differential equation?
A function.
It's a slope function. So this can give me the slope if I just plug that in, and I already have the point. So all I got to do is say, all right, and remember, you need to label your work. So do I do this? Do I say dy dx? Do I say, all right, e to the 0 times 3 times 1 squared minus 6 times 1? Do I write that? No, because that's not the slope. That's the slope. I want the slope at that point. So I say the slope at 1, 0. Label what you're doing. They need to see that, okay? And then what do I end up getting? 3 minus 6 is negative 3 times 1. So there's my slope. And then all you have to, it says write an equation for a line. So you probably got a point for that. Maybe, maybe not. Depends on how the rest of the problem is. I'm going to now say y minus the y coordinate, which is 0, equals slope x minus the x coordinate. And I certainly don't need to write y minus 0. I can just leave it like this. Either one. You definitely are going to get a point for the equation of that line. And then it says use that tangent line to approximate f of that. Okay? So if y is f of x, this is my function that I'm going to use to approximate. Do you remember tangent line approximation? The whole idea of it is there's some curve that's f, right? And I'm looking for some value, say right here. But I don't know how to do that. So what I do is I get a tangent, or maybe I know some slope. I know a slope and a point right there, but I'm looking, say, for the value there. I just don't know it. So what I'm going to do is plug that value in to my slope equation, and my hope is my result is pretty close because it's tangent. Tangent's got to be pretty close, as long as the number I'm plugging in is pretty close to 1. And sure enough, it is pretty close to 1. So I just plugged 1.2 into here. And you didn't have a calculator for that, but hopefully that's not a big deal. What's 1.2 minus 1? And what's 3 times 0.2? Negative, not 6, but move the decimal, 0.6, so 0.6. And you probably got, so you might have gotten 2 points for this. I doubt you got 3. It might have been, hey, if you get the equation right, we'll give you 1. And if you find that value, we'll give you 1. So call it a 2-point problem. And then B, might have been 3 though. B, the particular solution for the differential equation. So the whole rest of the problem was find the particular solution. This is so common on the AB test. And you got to know a little integration, you got to know the process, you got to separate variables, all that kind of stuff comes into play. But it's 6 points more than likely. I've never seen more 7. And it's almost every test I've ever seen. So, let's get started. You've got dy dx equals e to the y times 3x squared minus 6x. Any ideas?
Just move everything divide by e to the y and multiply by dx.
So multiply by dx, divide by e to the y, and I get 1 over e to the y dy, 3x squared minus 6x dx, plus 1, right there. Now when I go to integrate, is that a rule that you know? No. So anybody have any ideas? I see this all the time. Oh yeah, use that log rule. Can I do that? No, that's the rule for 1 over u. That is not a u, at least not yet. What other options do I have?
U substitution.
Okay, if I let u be that, then du is also that. So if that's my u, I don't have another one for the du. So I can't use this u substitution, although I am going to need to do a u substitution eventually. So that didn't work. Anybody? Okay, if I move e up, it looks a whole lot closer to a rule, but is it still a rule? Or is it a rule? Why not? Because there's a negative in there. So now I would do the u substitution for the negative y. So du is negative 1 dy. That I can work with. Are y'all seeing that? It's a great way to get messed up on this and start getting hammered on your points right from the start by not knowing a basic integral u substitution process. So I'm going to put a negative 1 in there to make it match with the dy, but I got to balance it by putting a negative 1 so that a negative 1 times a negative 1 would give me 1. That's no change. I'm going to circle that, and I'm going to circle that, and I'm going to make my replacements. So drop down the negative 1, e to the u, du, and then whatever you have here. So now I'm ready to go. And I know a lot of you probably go ahead and do the integral on the right, that's fine. So what do I get here now? What's the integral of e to the u? E to the u. So drop down the negative 1, copy down times e to the u, which is a negative y. And no, I don't really need that negative 1. I could just put the negative. And then over here, what's the integral of 3x squared?
X cubed minus 3x.
That's right. 3x cubed over 3 is x cubed. And minus 6x squared over 2 is minus 3x squared. Don't forget the c. So at this point, you had plus 1. Probably plus 1. This was pretty basic here. So probably this integral may be plus 1. This may be plus a half. Sorry. And maybe the c plus a half. So 1, 2, or at least at 3 points. And then you got to do what?
Move the negative over the natural log.
I can move the negative over, or I can solve for c right now, or I can move the negative over and solve for c a little bit later. You tell me. Solve it later. So if I move the negative over this negative, I'm basically multiplying both sides by a negative. This is going to change my c value, but it's okay. I get a new equation, negative x cubed, positive 3x squared. Technically a negative c, but it's still a c. So I'm just going to go to this equation now. Anybody got any ideas?
Go ahead and plug in y for 0.
So plug in 0 for y and 1 for x,
Yeah.
according to that. So I like to make a note of what I'm doing. I like to say, all right, I am plugging in 1, 0 in there. That way, if my answer is complete crap, like let's just say I have butchered these integrals, right? If I have a butchered integral and then I go and plug 1 and 0 in there, the reader might look at that and go, what are you doing? They can't follow your work well. But you literally, on the key that AP puts out, they literally go 1 point for entering 1, 0. Doesn't say for 1 point for entering it into the correct equation. So I just want to make it really clear that I am entering 1, 0. So I do that to make it really clear in case I have messed this stuff up. So plugging that in there gives me a 0 there. Well, e to the any 0 is 1. Plugging a 1 in for x gives me negative 1 cubed plus 3 times 1 plus c. So I end up getting a c of negative 1. Now, if you plugged it in here, your C is gonna be positive 1 if you plugged it into that equation. But I plugged it in this equation and I got C a negative 1. Different times are gonna give you different values, that's okay. But where do I make sure I plug it in? Not there, but here, right? So I'm plugging it back in there, and I get e to the negative y equals negative x cubed plus 3x squared minus 1. Right? And now I just got to clean it up. So what would you do? If you natural log the left, you get negative y. And what happens when you natural log the right? Well, you just get a natural log of a bunch of junk here. And then the last step, negate both sides. And I would think that your answer on anything AP would be true. Now I will say this, that there was a notation on the key that it said, this is true for all negative x cubed plus 3x squared minus 1 greater than 0. Do you know why they said that? Because there might be some x's out there. Like for instance, if I plug a 1 in there, I get negative 1 plus 3 minus 1. Well, that's positive, that would be safe. If I plug a 2 in there, I get negative 8 plus 12 minus 1. That's still positive, still safe. But there might be some x values out there, or in this case, yeah, this is x. There might be some x values out there that don't make that true, so they put this condition on there and said, hey, just in case. But I don't think that's something that I would probably not have remembered to write. A little domain, I would probably argue that it's not necessary because we as mature Apcalc students know that you can't log a negative number, or a 0 for that matter. Actually, I probably should have said, didn't say this on the key, but I probably should have said that. No, yeah, it has to be greater, it can't be equal to 0. Not too bad. 9 points, guys, on an AP test. 9. And I would take these all day. I loved differential equations when I took it in college. I mean, to me, it was this kind of stuff. It got harder, but it was not too bad. What about? Hey, got some time. 10 minutes. Do the homework problem. Yeah. And then you can just focus on your take-home quiz. It should be in your book, right? Okay, so here's 2010 AB6. This was a couple years before I started teaching this. You guys were running around Homewood Park with your buddies. 2nd grade, maybe, right? About 11 years ago, y'all were 7-ish.
Yeah.
That's like, is that 1st grade? 1st grade, 2nd grade?
1st and 2nd grade.
Yeah. So anyway, we're looking at this. It says solutions to that differential equation also satisfy this equation. Y is f of x. Let that be the particular solution to that differential equation at that point. Now, what did they basically give you? They gave you what? The differential equation, which is the slope equation, and then they gave you the second derivative, which is the derivative of this derivative. They cleaned it up for you nicely too. And what could that second derivative possibly help you with? What does second derivatives typically help me with? First derivative is slope, the second derivative is concavity. So there might be an issue of concavity on this problem. That's what I'm thinking, but I don't know. Let's just plug through and see what happens. It says write an equation to the line tangent to the graph. Here we go again. Tangent line approximation. So I have a point, x equals 1. Wait, that's not a point, that's a coordinate. Do I have the actual point that goes with 1? Yeah, they gave that to me right here. So I got the point 1, 2. Do I have the slope at that point? No, but I can find it from this, right? So if I plug a 1 in there and a 2 in there, what's my slope? So say dy dx at the point 1, 2 is 1 times 2 cubed equals 8, or at least say these two things. So I've got my slope. You probably get a point, half a point, maybe not anything. And then it says write an equation of the tangent line So y minus the 2 equals 8, x minus the 1. And you're wasting your time putting it in any other different form, in my opinion. Now it says, use the tangent line equation from this part A to approximate f of 1.1. All right, so I've got this equation. Can I approximate f of 1.1?
Yeah.
Yes. So I'm going to plug a 1.1 in there. And I really like the next question, I think. I haven't looked at it in a year, but I'm pretty sure I know what I'm about to ask. 1.1 minus 1 is 0.1. 0.1 times 8 is 0.8. And then when I add that 2 over there, I get 2.8. Now, here's the great question. Given that the function is positive, you see it saying that? Given that the function is positive, right? For values of x between 1 and 1.1, is the approximation for f of 1.1, that's the approximation for f of 1.1, right? Is that approximation greater than or less than the actual f of 1.1? Yeah, y'all remember problems like this? So think about a tangent line approximation. If my curve happened to be concave down, and I had a tangent line at 1 right there, and I plug in 1.1, and I plug in that value, the value that I get, if the curve is concave down, is going to be an over approximation of the real one, right? It's going to be bigger than that. But if the curve would have been concave up, right there at 1, then my 1.1 would have been an under approximation of what actually would have occurred. So what I need to know is, what was the curve doing at 1.1? Was it concave up or concave down? And I can tell that from the second derivative equation. So I come in here and I go, and it says justify your reasoning. So I'm going to say d2y over dx squared at 1, what was it? 1, 2. So at the point 1, 2, the second derivative is 2 cubed 1 plus 3 times 1 squared 2 squared. So it's 8, well, you know it's positive, right? It's nothing but positives in there. So I can go ahead and do the math. 4 times 3 is 12, 13. What do you get? A 104? Sure. Because it's greater than 0, the function f is concave up. Therefore what? F of 1.1 is it's on the tangent line, it would be below that curve, wouldn't it? So it'd be an under approximation. And that's a clever little question that you'll see. I've probably already talked about that a couple times this year, but it always seems to pop its little head up for a 1 point thing. So you probably got 1 or 2 points for A, 1 or 2 points for B, for a total of either 3 or 4 points, and then you get down to C, and what do they ask? Yeah. So I'm solving for the particular solution. I'm solving a differential equation. And if you're wondering why I'm only picking out like 2010 or 2013, because a ton of these problems I will use later on in the year when we do our big review. And I like to save the really, really current stuff a lot of times for our practice, so you really get an idea of what's going on real time with these AP thinkers. And a lot of times I'll give you practice tests, like real practice tests, and let you work on those actual problems, because we're going to have a 2-month review at the end of the year. That's my hope, barring like a total meltdown of society or whatever. Yeah, it's a little crazy out there. We're not talking politics.
Yeah, it might snow. It's pretty crazy.
True. Helmers has been telling us it's going to snow all week.
I heard in Mississippi.
Yeah, it snowed in Nashville.
Just south of us.
Snowed on Shades Crescent. You had to be up at 5 a.m. on Monday, though. It's kind of slushy. All right, one of my friends told me that last night. He lives up there. So check it out, guys. Here we go. Take my differential equation. dy dx equals xy cubed, and I'm finding it, the initial condition is f of 1 is 2, which you know is the 0.12. So help me out. Divide by the y cubed gives me this, and multiply by the dx gives me this.
Y to the negative 3.
That would be a +1, by the way. Integrate both sides. That's right. George said you can't go ln of y cubed, right? Because it's not y to the first. You're forced to rewrite it as a negative exponent. But that's great because that's a power rule. So the integral of y to the negative 3 is
Y to the negative 2 over the
y to the negative 2 over a negative 2. Technically plus c, but whatever. And then the integral of x is x squared over 2 plus the c. And you can solve for c right now. It's not a bad idea. You want to do it now or later?
Later.
Want to do it later? Okay, multiply by negative 2. That gives me negative x squared plus some other c. Now the c changed, so we're not using that top equation anymore. We're sticking with this one. Now, you might like that a little better now. All right, so let's plug in the 1, 2 now. 1, 2 gets plugged in right there. So I get 2 to the negative 2 equals negative 1 squared plus c. What's 2 to the negative 2? A fourth? Negative 1 squared? Negative 1 squared. Not negative 1 squared, negative 1 squared. Which is what? Negative 1. Be careful there, right? It's not quantity negative 1 squared, it's the negative of the square. So anyway, add that, you get a 5/4. Once you get your c value, plug it back into that equation. And real quickly, let me show you this, guys. What would be the best way to deal with this? So flip it, and then real quickly, what would be the best way to deal with this?
Multiply by y squared and divide by the rest.
So if that's this, you could multiply by y squared and divide by the rest, or couldn't you just flip both sides? Check it out. Flip that side, and look, flip the whole side, not each part. Flip the whole side, square root it, and then here's the last thing you gotta be careful about. What happens when you square root?
Plus or minus.
Now, it's not both. You then take your point, you plug a 1 in there, and does it give you 2 or negative 2? 2. Use the positive version. You tracking?
I just finished too.
All right.